Hello everyone, and then welcome to another video. So in this video we'll be treating eigenvalues, okay, finding the eigenvalues of a 2x2 and then what, a 3x3 matrix, okay. Right, so first we will start with what, finding the eigenvalues of what, a 2x2 matrix, and then after that we will just dive right into finding the eigenvalues of a 3x3 matrix, okay. Right, so without much ado, let's just dive right into this video. And then in case you are new to this channel, kindly subscribe, okay, hit on the bell icon so that you don't miss out on any uploaded video. Like the video so that other students who might need this video with their academics might benefit from the video, okay. Kindly share and then let me know your comments in the comment section or questions in the comment section, okay. Right, so with a 2x2 matrix or 2x2 matrices, you just need one formula, okay. It's very important, okay. So that's what the determinant of the matrix itself, okay, and then you subtract that from what, the identity matrix, and then what, the eigen what value, okay, and then you equate that to what, 0, okay. This is the most important formula you need to know, okay. Very important, okay. Right, let's proceed from there. Now, in case you don't know what an identity matrix is, okay, this is how an identity matrix of a 2x2 matrix looks like. So you have 1 0 0 1, okay. So once you multiply an identity matrix by what, an eigen what value, okay, so we have this. So this is how the identity matrix will now look like, okay. 0 0 and then what, identity matrix. So this is what we will be using throughout, okay. Now let's proceed. Now let's take an example so that we brace ourselves with the concept, okay. So let's say this is what, a matrix A, okay, which is equal to what, 6 16, okay. Then we have what, minus 1 and what, minus 4, and then you are told to find what, the eigenvalues of this what matrix. All you have to do is just quote this formula, okay. So we have a solution, so you just quote this formula, okay, and then you use the formula to solve what, the question, okay. Right, equal to 0. So let's proceed. So first you need to what, write out the what, the matrix itself, okay, the 2x2 matrix. So you have what, 6 16, and then you have what, minus 1 minus 4, okay, and then you subtract that from what, this expression. So this expression is over here. So we have what, identity matrix, oh sorry, the eigenvalue is 0, and then you have 0 and then the eigenvalue again. Now, so when you compute this, when you do the normal substitution, sorry, the subtraction, okay, you end up with 6 multiplying what, 6 subtracting from what, 6, that's 6 minus the eigenvalue, okay. So we have what, 6 minus the eigenvalue, and then we have what, 16, that's 16 minus 0, that's 16, and then we have what, minus 1, okay, then we have what, minus 4 minus the what, eigen what value. Right, let's proceed. So from here you could notice that this is quite simple, okay. So we are doing what, finding the determinant, okay, finding the determinant of what we've been able to what, prove, okay, and then we equate that to what, 0. So let's find the determinant of this 2x2 matrix, okay. It's quite simple. So we have 6 minus the what, eigenvalue, okay, and then you multiply that by minus 4 minus the eigenvalue, okay, and then you subtract that from what, 16 multiplying what, minus 1, so that's what, positive what, 16, okay. So let's expand this. So from here we have what, 6 multiplying minus 4 is what, minus 24, okay, and then we have what, 6 multiplying minus what, the eigenvalue, that's 6 eigenvalue, and then we have what, minus eigenvalue multiplying minus what, 4, that's positive 4, okay, positive 4 with the eigenvalue, and then we have minus eigenvalue, that's positive eigenvalue squared, okay, and then we have what, plus 16, okay. So when you simplify this further, you will end up with what, the eigenvalue squared, okay, and then we have this plus this will give us what, -2, okay, eigenvalue, and then we have 16 and what, -24 will give us -8. So after that you just equate that to 0. So this looks like what, a quadratic equation. So when you, in case you say what, your eigenvalue is equal to what, x, okay, this will be the same as what, x squared minus what, 2x minus 8 equal to what, 0. So with this you just use your calculator to find what, your x values, which is also the same as what, your eigenvalues, okay. So let's pull up our calculator and then punch our values, okay. Right, so we have, let's clear everything, okay. Right, so let's choose what, you click on mode and then you click on what, 5, that's equation, and then you choose what, the quadratic equation, okay, that's 3, okay. Now let's punch in our values, okay. We are punching in coefficients, okay. So coefficient of x squared is what, 1, coefficient of what, x is what, -2, and then we have our constant, that's -8, okay. Right, so we have our eigenvalues to be what, 4 and what, -2, okay. So we have values of x to be what, 4 and what, -2. So these are your eigenvalues, okay, since we know that x is the same as what, right, eigenvalue. Now let's proceed with another example, okay. Right, let's say example 2 or B, we have another 2x2 matrix, okay. We have -4, 2, and then we have what, 3, and then what, -5, okay. Let's try find what, the eigenvalues, okay. So you know that the formula, okay, so per the solution we know that the formula is what, matrix, which is what, A. So let's say this is what, B, okay. Let's make some few changes. Let's say this is B, okay, so that you get to know the dynamics, okay. This matrix B is equal to what, right, so since this is B, so our matrix will be what, B, okay, minus what, the eigenvalue multiplied by what, the identity, equals 0, okay. So let's see how we go by that. So we have what, -4, 2, okay, and then we have 3, -5, okay. Right, and then you subtract that from what, identity eigenvalue matrix, okay. So you have that's 0, 0, right. Now let's simplify this further, okay. So it's just simple subtraction, okay. You are just doing simple subtraction, okay. Let me just write that down here, okay. So we have what, -4 minus what, the eigenvalue, then you have 2 minus 0, that's 2, okay. And you have 3 minus 0, that's 3, and then you have what, -5 minus an eigenvalue, okay. So now we have what, determinant of the entire what, expression, okay, to be equal to what, 0. So let's proceed from there. So you are taking the determinant of the entire what, matrix. So we have what, -4 minus the eigenvalue multiplying what, -5 minus the eigenvalue, okay. Then you subtract that from what, 6, okay. So multiplying this by that, and then you end up with what, 6, okay. Right, so let's expand this. Let's try expand that. So we have -4 minus 5, okay. -4 multiplying -5 is what, +20, okay. Then we have what, -4 multiplying what, minus what, the eigenvalue, so that's what, positive what, 4, that eigenvalue, and then you have what, minus eigenvalue multiplying what, -5, okay. And that will give us what, positive what, 5 eigenvalue, okay. And then you have what, minus eigenvalue, so multiplying minus eigenvalue, okay. So that's what, positive eigenvalue square, okay. And then you have -6, okay. Right, let's simplify this further, okay. So we have what, eigenvalue squared, okay, and then this and this, okay. 4 eigenvalue plus 4 multiplying eigenvalue give us what, +9 eigenvalue, okay, and then we have 20 minus 6, okay, most definitely that will give us what, 14, okay, and then you equate that to what, 0, okay, yes, per the formula, okay, right. So let's simplify this further. So you know that eigenvalue, okay, is equal to x, so therefore we have what, x squared plus 9x plus what, 14 to be equal to 0. So now let's try find the eigenvalues, okay. Let's pull up our calculator, okay, right. It's in quadratic form, okay, so let's just punch in our what, coefficients, okay. So we have coefficient of x squared is 1, coefficient of x is what, 9, then we have our constant 14, okay, coefficient to what, constant to what, 14, right. So this will give us what, minus 2 and then what, minus 7, okay. So we have x values to what, minus 2 and then minus 7, right. So you can notice that this is quite simple, okay, very simple, right. Let's proceed to what, find the eigenvalues for what, a 3x3 matrix, okay, right. Let's dive right into that. So let's find the eigenvalue for a 3x3 matrix, okay, right. Let's proceed. So for a 3x3 matrix, okay, for a 3x3 matrix you need specific formula, okay. It makes the calculation very simple, okay, and straightforward. So this is the formula, okay, that's the main trick. The only trick you need, okay, is the formula. There's no need to go by solving any form of 3x3 matrix in order to end up with what, the eigenvalue. You just need the formula and then you are good to go, okay. So let's take a look at how the formula looks like. So this is the formula. So you know that the determinant of any matrix, let's say maybe A, and then we have that, should be equal to what, this formula, okay, minus what, eigenvalue q, okay, plus tr, okay. So I'll explain this later. So let me just write out the formulas for you, okay, and then we have minus pm, okay, pm of the matrix, okay, multiplying by the eigenvalue, and then we have multiplying the det, okay, of the what, matrix, okay. Now let's see how we go by finding what, the tr, okay. So tr, okay, is the same as the trace of what, a matrix. So let's say we have a matrix in this form, 1 2 3, and then let's say 0 1 5, and then we have 2 3 1, okay. So finding the trace is just adding or summing up the diagonal, okay. So for me, you can notice that the diagonal is what, 1 1 and 1. So the trace of this 3x3 matrix is what, equal to what, 3, okay. We sum up the diagonals, okay. There's 1 1 and 1, so you sum up the diagonals. Now let's proceed to what, finding the pm. How do we find what, our pm, okay, pm of the matrix, okay. Now this is how you find your pm, okay. You take the determinant of the entire what, of the entire sections of the what, the matrix, okay. So let me just write out a certain formula, okay. It's quite cumbersome, but it's very important. So we have 3 2, then we have a 3 3. So don't pay much attention to the formula I'm writing. I'll just use values so that you get to understand it better, okay. So we have a1 1, a1 3, and then a3 2, and then we have a3 3, okay, right. And then we have what, the determinant of the last one, okay. So we have a1 1, a1 2, a2 1, and then we have a2 2 2. Okay, right. So let me use an example so that you get to understand. So let's take this for example. Okay, let's take the same example over here, right? So we have so in case you are given similar question, okay, of this format, okay, all you need to do is just find out the determinant of sections of the matrix. Okay, so we have 1 2 3, and then we have 0 1 5, and then we have 2 3 1. Okay, so in case you've watched my video on how to find the determinant of a 3x3 matrix, okay, you'll be able to understand. It's quite simple. Okay, so all you are doing is just find the determinant of sections of the matrix. So let's take 1 for example. So when you take 1 as your reference point, anything below, okay, and beside 1 isn't included. So this is not included, this is not also included. Okay, that's taking 1 as a reference. So we have the determinant of 1 5 3 1. Okay, right, and then this is the determinant. Okay, and then you proceed. Okay, right, so you proceed toward 2. So anything below and beside 2 doesn't count. Okay, so these don't count. Okay, and then 1 and 3 doesn't count. So we have 0 5, okay, and then we have 2 1. Okay, that's how it works. Okay, and then we move on to the third one. Okay, so we have 3. Okay, anything below and beside 3 doesn't count. Okay, so we have these don't count, and then these don't count. Okay, so we are left with these. Okay, so we have 0 1 2 3. Okay, so this is how we find out PM. That's something like minor determinant. Okay, right, so let's proceed. So let's take a quick example. Okay, so for finding the determinant of the entire matrix, I will teach you a specific trick you'll use. It's very simple and straightforward. Let's take an example so that we call it a day. Okay, so let's say we have example. So let's say we have matrix A to be equal to 3 minus 1, okay, and then 2, and then we have minus 1 1 0, and then we have 2 0 1. Okay, let's see how we find out the eigenvalue of this 3x3 matrix. So first you need to write out your formula. Okay, the determinant of the matrix A minus the identity and then eigenvalue, sum that up towards 0. So that is also equal to minus the eigenvalue Q, okay, plus the trace, okay, the trace of the matrix multiplied by eigenvalue squared. Then you have PM of the matrix, okay, multiplied by the eigenvalue, and then plus the determinant of the entire matrix, right? So let's proceed. This is very simple. Okay, so first we have minus the eigenvalue Q plus trace. So let's find the trace of this matrix. So let's find the trace. So the trace of this matrix is just summing up the diagonal. So we have 3 1 and 1. Okay, so I have 3 plus 1 plus 1, that's 5. Okay, so we have 5 eigenvalue squared. Okay, and then we have minus PM. So let's see how we find PM. Let's see how we find PM. So we have this matrix A, okay, to be equal to 3 minus 1 2 minus 1 1 0, and then we have 2 0 1. Okay, right, so let's see how we find that. So taking the determinants, we take the exact determinants. Okay, so keep that in mind, the exact determinant. So taking 3 as a reference point, anything below and beside 3 doesn't count. Okay, below and beside, okay, anything below and beside 3 doesn't count. So we have 1 0 0 1. Okay, and then we move on. Okay, determinant of moving on to minus 1. Okay, so for minus 1, anything below and beside -1 doesn't count. Okay, so below, anything below and beside -1 doesn't count. So we have what? -1, 0, 2, and then what? 1. Okay, 2 and 1, and then we proceed. Okay, find the determinant of the third one. Okay, so it means that we take 2 into consideration. When you take 2 into consideration, it means that anything below 2, okay, and beside 2 doesn't count. Okay, so we have what? -1, 1, and then we have what? 2, 0. Okay, now let's proceed. So let's find the determinant of this. Okay, so when you find the determinant of this expression, okay, when you find the determinant of this expression, you end up with what? 1 minus 0. Okay, so this will multiply 1, 0 multiplying 0, so 1 multiplying 1 minus 0 multiplying 0. Okay, plus the determinant of this, so we have -1 multiplying +1. Okay, so -1 minus 1. Okay, so -1 multiplying what? +1. So we have what? -1, and then -2 multiplying what? 0. Okay, so this -1 multiplying 1, and then you subtract that from what? 2 multiplying 0. Okay, so that's 0 over here, and then you have what? -1 multiplying 0, that's what? 0, and then 2 multiplying what? 1 give us what? 2. So when you compute this, you end up with an exact value. Okay, an exact value of what? 2. Keep that in mind, an exact value, right? So let's proceed to find what? The eigenvalue. Okay, so from here we can notice that we have a PM of the matrix to be what? 2, and then now let's find the determinant of what? The entire matrix. Okay, so this is where the trick comes in. Now all you have to do, you don't have to do anything. All you have to do, you just have to do one thing: pick up your calculator, and then I will show you. Okay, right, just pick up your calculator and I will show you. Now first thing first, clear everything. Okay, clear everything from your calculator. So shift 9 3 equal to sign, and then you click on AC. Right, so from here you click on mode, you choose 6, that's what? Matrix. Okay, and then you click on 1, that's for matrix A. Okay, and you choose what? 1, that's what? A 3x3 matrix. Okay, now you insert your 3x3 matrix, so you have what? 3 minus 1, you have what? 2. Okay, and then you click on what? -1 again, you have what? 1. Okay, you have what? 0, and you have what? 2. Okay, you have 0, and then you have what? 1. Okay, right. So after doing this, note, after punching this, click on AC. Okay, click on this one. Right, so after this, just click on AC. Okay, click on AC, and then after clicking on AC, you go back and click on what? Shift, and then you click on what? 4. Okay, 4. This list will just pop up, and then you click on what? 7. Okay, click on 7, and then you click on Shift again, you click on 4, that's matrix, and then you choose the matrix you initially used. Okay, that's matrix A, so you click on 3. Okay, right, and you close the bracket. After that, you click on the equal to sign. You'll be given the what? The matrix, the determinant for the entire matrix. Okay, so the determinant for the entire matrix is what? -2. So you just put that over here. So let's clean this up. Okay, so we have what? -2. Okay, so all you have to do right now is just this what? An equation. So let's say this equation 1. So all you have to do is just multiply equation 1 by what? -1, so that you can get rid of this negative sign. Okay, so this equation will then be reduced to what? Eigenvalue Q. Okay, let me rewrite that, since cannot see from here. Okay, so let me rewrite that. Okay, so we have what? eigenvalue cube, okay, and then we have what? So this is what we've multiplied -1 throughout, so we will end up with what? Minus what? 5 eigenvalue squared, okay, and then we have plus 2. There is an eigenvalue over here. I didn't introduce that, so just insert that over here, okay, and then we have what? Plus 2, okay. This should be equal to 0, okay. So now this is the same as what? A cubic expression, okay. Let me rewrite that over here so that it could be seen clearly, okay. So minus 5 squared, and we have what? Plus 2 eigenvalue, and then we have plus 2 equal to 0. So this is something like a polynomial, okay. So all you have to do is just find the roots of the polynomial, okay. So let's say our eigenvalue is equal to what? X, okay. So we are just substituting, just like for the 2 by 2 matrix. So we have s cubed minus what? 5s squared plus what? 2x plus 2 is equal to 0. So now you might be thinking of using values to check and then find your root, just like the method for polynomials insists, okay. So what if I told you there's no need to do that? You could just find your answer right away, okay. So this is how you go by that. First, you pick up your calculator again, okay. Pick up your calculator and then you punch. Let's clear everything out first, okay. Right, so you just punch this, okay. So click on mode, click on 5, that's equation, and then you click on what? 4, that's cubic, okay. Click on 4 and then you punch the coefficient of these equations, okay. So first you have s cubed to 1, 5 and s squared to what? Minus 5, and then you have x to what? 2, positive 2, and then we have our constant to be what? 2, okay. Right, so after this you just click on what? Equal to sign, okay. You'll be given all the 3 roots, okay. So you have what? 4.449, so let's say 4.45, 1, and then what? Minus 4.49, so that's minus 0.45, okay. So let's see, we have our roots to be what? We have 4.45, and then what? Minus 0.45, okay. So once you do this, you end up with what? The exact value. So in case you use a polynomial approach, you might end up with something like a 2 plus root 6, okay, 1, and then 2 minus what? Root 6. Note that 2 plus root 6 is the same as what? 4.45, and then I will prove to you, okay. And then 2 minus root 6 is the same as minus 0.45. So let's see. Let's prove that, okay. Right, so let's prove that. So let's see what 2 plus root 6 will give us, okay. So we have 2 plus root 6, okay. Right, let's see what the answer would be, okay. So you can notice that it's the same as what? 4.45, okay. And let's check for what? Negative root 6, okay. Let's check for negative root 6. Right, so you could notice that we have the same value over here, so minus 0.45, okay. Right, so this is how you go by solving what? The eigenvalue, or finding the eigenvalue for 2 by 2 and what? 3 by 3 matrix, okay. Right, so kindly subscribe to this channel in case you want to see more of such videos, or some of these videos which will help you or help augment your studies. Kindly like so that it gets pushed to other students who might need this video in their academics, okay. Kindly like the video, share the video, and then if you have any questions, just leave them in the comment section and then I will reply to them as soon as possible. Have a lovely day. Bye bye.